All right, so next we are going to move on to our next panel discussion, which is around the topic of blue-green roofs and benefits and challenges to innovative water management. And this panel is going to be moderated by Jennifer Bousselot. So Jennifer, I'm just going to turn it over to you and let you introduce the rest of your panel there.
Thank you, David. I appreciate that. I'm delighted to introduce an incredible panel today. We have Dr. Karen Liu, a green roof specialist at Next Level Stormwater Management, Richard Hayden, the green roof and blue roof department manager at American Hydrotech, Kees Govers, the technical sales manager for Liveroof Ontario Incorporated, and Jeremy Wright, business development and project manager at Zinco Canada. So welcome panelists. We're delighted to be talking about this fascinating topic, demystifying the blue-green roofs, benefits and challenges to innovate water management. So let's jump right in and let's make sure everyone's on the same page and talk about what the difference is between retention and detention.
Well, who wants to start?
I guess I'll start. Why not? So, to our understanding, the retention is whatever you can capture on the roof that does not leave via the drains. It leaves as water vapor in one form or another. Detention is for however length of time you detain the water on the roof before it actually leaves the building typically through drains. That's probably about as simple as I can put it.
Terrific. Thank you, Kees. I appreciate that. Next, what are some key principles needed to design a blue-green roof for stormwater management?
Structural capacity definitely needs to be factored in. Obviously, if you're doing something with 6 inches of ponding water, you're going to have a lot more weight involved in that assembly. So that needs to be thought of well in advance, and how that's going to tie into the overall stormwater management plan of the site as well. I think that's two of the things that we can probably all agree on.
I think understanding where what the stormwater management plan for the entire site is, and understanding the value of the below grade and above grade and the rooftop spaces are. Because I think that the economics of these projects comes into play more often than we think, because the owners are trying to find the easiest and least expensive way to deal with this, because the municipalities are, like what Kees is saying, is that the municipalities are governing these detention requirements, and that's actually harder to do than to do a retention roof. And so I think in many ways, knowing what the whole package looks like, even though we tend to focus on the roof, knowing what the whole package looks like helps give the owner at least an understanding of here's where some of the trade-offs might be.
Absolutely. And I think looking at the whole site, we're also looking at not just the volume that is going to be retained and the detained, which can be regulated by the government and the local authority, but also at the same time, the release rate as well is quite important. So oftentimes we have to design with the release rate in mind as well.
And that ends up bringing in people that you just don't normally deal with. You bring in mechanical engineers, like Jeremy's saying, you got to have a structural engineer has to look at this, because when you start adding 6 to 12 inches of water on a roof, this starts to add some weight. And some of these roofs you're just not going to do. A big box retail, for instance, if you're doing lightweight roof construction, probably isn't the best place to do this. Ironically, you'll probably find those types of constructed buildings in more suburban or rural areas where the cost of land at grade probably makes more sense to put your stormwater. But in the urban areas where buildings tend to be more permanent and more substantially constructed, that's where like Jeremy says, getting the structural engineers on board just to kind of understand, saying, all right, so if I want to add this, what would that take?
I think it's definitely a collaboration between, you know, structural engineer, mechanical engineer on the drainage, civil on the whole site, and also obviously the supplier, the designer, the architect, the engineers, everybody is involved with.
Absolutely.
Yeah.
Yeah, probably the other thing to think about too is, you know, what is the building owner going to do with the building? You know, for example, if we manage to eliminate a couple of stormwater tanks below ground by utilizing a green roof on the roof, you know, what is that worth? You know, if you're in downtown
Exactly.
if you're in downtown Toronto, a parking spot, I've heard them go for $80,000 to $100,000. Now that's Canadian, but still,
Still expensive here on the other
it's
side.
still expensive. And actually, I've seen numbers batted around that a parking spot actually costs about $80,000 to build in Toronto. So, you know, you're looking at something. If you take a bunch of the stormwater management to the roof, where you're typically not fully utilizing your roof anyway, there's a lot of gain to be made. So that's one of the reasons why really the entire design team needs to sit around the table when the concept of the building is being put together, rather than adding bits and pieces after the fact. Drawing in a blue-green roof design just before you go to permit is probably way too late. You know, it's something that needs to be thought of before site plan approval, possibly even at the time we are looking for rezoning.
Excellent, thank you all. Does a blue-green roof need to be on a flat roof or low slope roof, or can it be applied to sloped applications too?
Well, you can do it on sloped or flat. You do lose a substantial amount of water capacity with any slope. I don't care how gentle that slope is, you're going to lose some water. Usually you lose sometime around half. It's a formula of an inverted pyramid. And looking at what that does, even if you've got 2% slope, that's chewing up a lot of water, storage capacity. And flat deck, some municipalities don't like that. Some consultants don't like that, but Washington, D.C., for instance, and Chicago, but Washington, D.C. actually has a part of their building code that says if you're going to do that, you have to use a membrane that's designed for a flat deck. Flat deck's done all over the country. It's actually done in Canada too. But some consultants are a little weary of it. But a lot of designers, a lot of architects say, we do that all the time. So let's just do this. Mm-hmm. The water gets to the drain, which is they're really explaining that to people, saying, well, how does water get to a drain in a flat deck? Well, it's physics, and that's how that works. It's hard to put on paper, but it is you can visualize that.
Yeah, but I think with the building, even though you build it flat, but sometimes, like you cannot be absolutely flat. And so sometimes it can be the reverse, the deflection of the building, especially with loading, with the equipment, you might actually get like the other way, like a negative slope. So I think this is why in Canada, at least, most of our roofs are not 100% flat, and they recommend a minimum of 1% to 2%, minimum, and sometimes even 5%, because you have to account for the building it and the deflection over time. And in order to get that little bit of help, to move the water around. And as you said, like with the slope roof, you will lose some amount. And I was doing some little bit of calculation just for myself, like you do, Richard, with the inverted pyramid. So you can get, it depends. If you have a lot more water, then you lose less. But if you have like a minimum amount, let's say 2 inches, 50 millimeter, 100 millimeter, 4 inches, and you do lose about like maybe 60 or even like 70% in that case. So but there are ways to get around it, right? Which it is possible that you can build, for example, check dams, to distribute the water to the further away from the drain. If you're doing that way, or there are other methods. For example, using friction detention blue-green roof is also a possibility that to collect the water, by using friction just right on the surface. And then that way you are allowed to go with the slope without worrying so much with that as well. So I think that are other possibility that we can get around the slope.
Sure. I think that a lot of pool decks, for instance, that have pavers around them, where you've got pavers on pedestals, that's an ideal place. And that's often done on slope. And so you have that space in between the pavers, in between the pedestals, where the water can collect underneath there. You don't want to get the pavers submerged for any length of time, but there's that space that tends to be wasted or tends to be there because they needed a little bit of room to put these pavers in and with the pool deck. But that's a great place to be able to do that.
Yeah, and to build on that, that's already where you have a lot of load bearing capacity because you have a ton of water sitting there already.
Well, from what I'm seeing too, from the all the older buildings that are being retrofitted, a lot of the plaza decks actually do have kind of perfectly built 0-degree slopes. A lot of them are really well made, but it's tough sometimes when you're dealing with consultants that aren't experienced with it on these newer builds. But a lot of these older buildings that are kind of in the retrofit stage, a lot of them do have these 0-degree roofs. But another point that I think often is discounted, even just from, it doesn't necessarily have to be a blue roof all the time with the green roof on top. You can use slow release drains on more roofs than you think. And it doesn't necessarily require a 6-inch ponding element or retention spacer underneath or whatever product the supplier is providing. But it's pretty impressive from an overall site stormwater plan, what the difference between a slow release drain is to one that's not slow release. So I think the industry in general probably could utilize more slow release drains than anything on even just traditional green roofs. Obviously, you have to take into effect that you're not ponding and drowning the plants around the drain outlets, but there's definitely a pretty good opportunity for mechanical consultants to start utilizing slow release drains on even just our traditional sedum roofs. And provide some of the benefit that we would when we're using a blue-green roof assembly as well.
What we find is real interesting is talking to the civil engineers know exactly what you're talking about, Jeremy, because they do that every day at grade.
Yeah.
Parking lots are done that way all the time.
Yeah.
You put a restrictor in a storm sewer and that restricts the flow of the water off a parking lot. And that's been done for 50, 60 years. And then what you're describing is a roof drain that's been around for probably close to 100 years, because back when we used to use, when the building world used coal tar pitch roofs, you had to keep it cool in the summertime. And so they would deliberately flood the roof to keep it cool. And they'd have ballast stone up there and they keep that roof cool by just flooding it. Well, now, hey, and that was way back when, we can't do coal tar pitch anymore. It's a great membrane, but it's a carcinogen if you ever remove it. And so it's taking on another form, it's taking on another use. And so engineers know how to do that. They say, oh, this hole takes or has a release rate, like Karen's saying, has a release rate of so many cubic feet per second. We can put that into the stormwater calcs, and it's actually fairly straightforward.
I think you have a good point about, like we are not using coal tar pitch anymore because it's carcinogen, but it is a waterproof, very good waterproofing membranes, and we all know that. And I guess one thing about Jeremy talking about like, oh yeah, we can use it on more different type of roof, but we also have to make sure that the roofing membrane itself is actually able to support that, and also with the roofing warranty as well. So sometimes it's not like you can just go and retrofit it, because like if the roofing membrane was not one of those types, then it's not a good idea.
Right.
Well, I mean, that's something to check with the roofing manufacturers to see what kind of warranties they give on their membranes. So when the selection is made of what kind of membrane you're going to use, it has to be something that is suitable for ponding, and where there's no restrictions, or very well defined restrictions on how long water can stand on it.
And that's a byproduct. Like if you're looking at, Richard, please correct me if I'm wrong, if you're looking at a monolithic membrane compared to a torch applied modified 2-ply membrane, when it comes to ponding on a 2-ply membrane, it depends on the manufacturer and how that bleed detail is, right?
Right.
Like the size of it and what their specifications are on that, because we have had experience in the past with some suppliers. Like, we're not a membrane supplier, we typically work with everybody on that, but some suppliers, depending on their specification on the bleed size and how that membrane is actually being adhered, you can actually do ponding on it, or they have a certain amount of time that the water can sit on it. But then it really depends on what the spec is on that membrane. Obviously, a monolithic membrane is way better to go with, but it's just not always on every job.
Well, and in full disclosure, I am a membrane manufacturer. I represent one, just so everybody recognizes that. I think most of you do. But I do believe that a membrane that's seamless and bonded to the deck, that's the real key. And there are a number of membranes that do that. That's a really important part of this, because this is not the kind of a facility that you just pick up and repair the roof. This is, or if the membrane just happens to go bad for some reason, it needs to be something permanent. The other part of this is that depending on what assembly that you're using, the insulation is typically on top. And so the insulation then plays an important part of these calculations. DuPont, who makes styrofoam, and all of the XPS insulation manufacturers have some limits on how long that water can be underwater, or that insulation can be underwater. They don't want moisture drive to drive into the insulation. And that's common for any XPS, extruded polystyrene insulation. And so that actually becomes the outside limit. Typically it's 48 hours. They don't want that submerged for more than 48 hours. And that's where, in many instances, that actually corresponds to what the cities want. Cities say, I want that water gone in 48 hours, because the nice part about this assembly is that it creates this back-to-back-to-back stormwater capability. And so, like in Toronto, I know you have a lot of storms that are every other day. We're going to get some of those coming up in the next week here in Chicago, where the storms are going to be hitting Friday and then Sunday and then I think Tuesday. And these types of roofs can handle things like that, because they're constantly emptying and constantly filling. And so that's the real beauty of what this is all about.
Yeah, just to give you a quick example of what lack of vapor drive can do. Early on, when I got into green roofing, I was involved in a fairly large project where there was a 25-year-old roof, which was an inverted roof that had been sealed up. It only had 2 inches of insulation on it, XPS. But since it had been sealed up, it had picked up water. So a 2 by 8 foot board of insulation, rather than weighing, about 12 pounds. Now wow. was weighing about 200 pounds, and they had to be picked up with a forklift. So, you cannot restrict the vapor drive in an inverted roof. You have to make sure that there's enough, vapor diffusion open space, I believe it's called.
Yeah, open diffusion.
Yeah, and that's supposed to be 65% open. So you can only have 35% of the actual insulation covered with product, directly covered with product.
I think we are talking about mostly in inverted roof, but also there are opportunity for conventional roof as well, where the insulation is underneath, and then we can probably get around that. But with Plaza Deck, a lot of that is inverted. So so we tend to work with that. But also there are also opportunity, for example, with spray polyurethane foam. It is an insulation, and then also it can also act as a waterproofing as well. So there is another opportunity that can also as a base for this blue-green membrane as well. So
Well,
I think we should look into other methods as well, not just like one type.
Well, keep in mind that PVC and EPDM have traditionally been used as pond liners. So you know, when I got into the industry, I had I met Terry O'Connor fairly frequently. For those of you who remember him from Firestone, basically what he told me was the best roofing system under a green roof is the one that's installed correctly. It doesn't really matter what it is, as long as it's warranted properly and as long as it's installed correctly. And you know, that's still, from what I've seen over the years, that's still true for every roofing system there is. So the quality control is as important as the materials are.
Yeah.
Excellent. Are there any other points? Sorry, Karen.
Oh no, I was just going to say, like, no matter what, like the roofing is the key, because you have to get it watertight. And if with the EPDM and single ply, they are usually much wider than, let's say, modified bitumen, and then they have less seam. So less seam means less chance of like the roofer having a bad day or something like that. So so sometimes it's a workmanship. I think it may not be the material itself, but the workmanship, you know, like
it's that bad lunch concept.
bad hair day
or breakfast. Yeah.
Actually, that what we've missed so far really is you know, the testing before you actually put anything on the roof. So making sure that waterproofing is in fact doing what it's designed to do, and that the workmanship is good before you put, you know, X amount of pounds of overburden per square foot on it. So that's really the key. You know, there's quite a few different ways you can do that, but if you want anything long term, you're into electronic field vector mapping, you know, where you can put the system down on the roof, you can test it before you put anything down, and you can come back 5 months later, you can come back 20 years later, and you can retest it even with the overburden in place. And that's one of the key things, I think, when you're, especially when doing a sizable blue-green roof, and especially if it's over a critical building, you want to put EFEM test system in place.
Great. This has been an incredible discussion so far. We jumped right in and didn't establish a definition for a blue-green roof. Should we try to do that at this point?
That's a really good question, because I'm seeing it batted around a lot. And you're going to get probably 4 different answers with the 4 of us here. Which is the best thing to do. You know, it's awesome. So I'll start off with my definition of it. In that instance, and just from where the green is separate from the blue, there are several different ways to look at that. And so where the green is over the top of the blue, and the green part provides the retention and the blue part provides the detention. And I say that mostly because of our experience in some of the municipalities, is that Chicago, for instance, doesn't look at the retention of the green roof directly in relation to the blue roof underneath it. They take those as separate calculations. And that becomes a frustration, because it's not a directly measured or directly calculated function, very much like the calculations that you see in Washington, D.C., for instance. So that's my short definition.
Yeah, I like your definition, and I agree with you that, you know, like with the blue, just say when we say blue roof and green roof, they are linked together. And one thing I want to maybe point out is it can also be the blue and the green are directly connected together, like even though they're one on top of the other. So, but we want the plants to be able to access some of this water, in the blue roof as well. So there are ways that you can actually allow the water to pond, for example, into the green roof and allow it to drain again, within 24 hours or 48 hours as well. So that is also a possibility. And not only when you're doing that, not only you can increase the retention, you can increase the retention as well as doing the detention. So for example, as I mentioned about, there is a way that you can, for example, put a friction drainage layer right at the bottom. You can allow it to pond the water, so that now that your green roof and the blue roof are linked together, even though of course the water is closer to the bottom as well, but you are delaying the water by the blue and retaining the water by the green. So you get the best of the both worlds.
Mm-hmm.
I think also, Richard, to your point about underneath pedestals, for example, in paver areas as well, I like to think about blue-green roof technology as like true optimization of your space. So being able to value in those hardscaped areas that don't have any evapotranspiration area or retention capacity to it, but you can use it as a stormwater management tool, obviously a byproduct of how that water is flowing out and how the overall roof is designed. But unfortunately, I don't want to be the bearer of bad news. We all know that it's cheaper to do a blue roof with a control valve on the drain than a green roof if you're looking at the green roof just as a stormwater management tool. So it's that ability to connect biodiversity, enhance green space, use evapotranspiration, like true evapotranspiration from vegetation, against a traditional blue roof, which is really just a controlled release of a ponding membrane, which is not new technology. Europe's used blue roofs without vegetation on it for a while, whether it be active control or slow release control with no vegetation on top. So like blue-green roof technology is basically being able to, sandwich all the environmental benefits of a green roof while also trying to enhance the overall stormwater management benefit.
Yeah, but I think nowadays we are always expecting something to do multiple purpose,
Sure.
So you want a roof is just a roof, right, to start with. But now we say, no, we want the roof to be supporting biodiversity. We want the roof to be managing stormwater. And perhaps we should even integrate solar, blue, green roof together.
And don't forget the barbecue. We got to have the barbecue up there.
Yeah.
And we have the fridge to put the beer in, right?
Right.
Yeah.
I mean, that's why we're here, isn't
We
it?
cool the beer.
Yeah,
Well,
and
no,
of course,
go ahead.
yeah, of course, you have to make sure that the people on the amenity spaces don't get their feet wet as well.
That's yeah.
So, but to come back to some of the other points, that you can integrate a lot of these things if you really think it through well. But again, it comes back to the point that we made very early on, that everybody in the design team has to be on board in order to do that, to take advantage of that. So you can create a green roof like the one behind Jennifer's on Jennifer's background as a blue-green roof, despite the fact that those plants can't really stand water. So you have to make sure in the case like that you do not have water backing up into the green roof system, but that the plants can still access the water. So there's a fine line, and when you get into plants, and I've been a horticulturist for 35 years, some plants can handle inundation, some can't handle inundation at all. Sedums are one of those, and something is halfway in between, and then you also have the drought tolerance. So a sedum is extremely drought tolerant. They can absorb very large quantities of water. They can't sit in water. Conversely, grasses, if you let them dry out, well, then they're no longer a good evapotranspiration deal. Yet when they're green, their evapotranspiration potential is multiple times that of sedums. So it's a fairly sizable puzzle that we're putting together for each project, depending on what the design team thinking about, and that's one of the key things why this really should be done when the building is being conceptualized.
Mm-hmm.
Yeah, and I think that's a very good point about the plant. And thank you, Kees, for bringing it up, because I think this is also one thing about, we always hear about talk about demystification of the blue-green roof. And one thing is the water is not going to be stagnant there for a long time. So just like earlier we established, like Richard mentioned, it could be 72 hours in the Chicago area. And in Ontario, we know that it is supposed to be 24 hours. The water has to come off. So meaning that you are only going to, saturate all the green roof, and then the water is going to come out very quickly within 24 hours. So the plants are never going to stay sit in a pond. They're not going to be like a water lily kind of idea. So I think that's also is important to know, when we are designing, that we are actually saturating it, allowing more water storage in the soil than they would be, if it's just without the blue element. And then now also they are never going to sit with the wet feet. And I think that's also is an important thing to know.
Yeah.
It'd be interesting to speaking about the wet feet scenario, and I'm much newer in the industry than the rest of the panel, so I'm definitely fortunate to be featured on here. But from the amount of calls I've got for roofs that a client's looking at, if it's failure or what's going on with my green roof, from what I'm seeing, it's a bit of a mixed bags of roofs that are completely dead because they didn't get any water at all, but also roofs that are completely saturated because they're not draining at all. It's mostly just like a moss environment, which depends on what you deem as a failure or not. But I'm totally interested to see what more of. And again, I'm privy to Canadian climate from Montreal, Vancouver, and Toronto. But if there's more roofs that are too saturated, or if there's more roofs that are not saturated enough. Which I guess is kind of going to be included in this balancing act of figuring out how to streamline blue-green technology as well.
I would wager that many of the roofs in the United States are going to be drier than what we would like.
Yeah.
Because most of them are not irrigated. Those that are either the irrigation does not work, or it's not been turned on, or it has not been maintained.
Mm-hmm.
And that's where sedum, like Kees is saying, sedum is one of those ones that does, well. I was just up on a roof here at Northwestern Biomed up the street from Hydrotech. And, we're in a drought here in Chicago. We haven't had a lot of rain until last weekend. And I was up on the roof 2 Tuesdays ago, and the roof was amazing. Could not believe it. And there was water. You could look in the drain. There was a little bit of water at the base of the drain bowl, but otherwise that roof was dry, and the sedum were going nuts. And I was just like, wow, okay, so that's great. But my suspicion is that if it's a standard green roof, they're pretty much on the dry side.
Yeah.
When you say,
and Richard, I think if I have to gear towards too much water or too less water, probably too less water is a bit better than too much water, because we always want a good drainage. We don't want standing water. It's not good for the membrane. It's not good for the plants.
Well, and too dry a media is bad for the media too, because I've had that happen.
Yeah.
We have a project in Phoenix where they didn't get any rain and they didn't get any water from external sources, and the media became so dry it was hydrophobic. And that can happen also. And that brought up the memories of a presentation that was done at University of Maryland, where one of the students did just that. Said, if you're going to use your roof for stormwater management, please make sure it gets a reasonable amount of moisture, because it needs that to keep that water, that sponge alive, that keep that sponge active.
Yeah.
So
a growing media that supports plants has to have at least 10% water in it. When it drops below that 10%, you get into trouble. So, the example of Phoenix, and I've seen one in Calgary, when you're in those dry neighborhoods, Southern Ontario, things are very dry at the moment as well, but not to that point yet. But to come to Jeremy's point about dead green roofs, and I think we probably all attest to this, most of the dead green roofs that we encounter are construction related. We encounter them within the first 6 months after they're installed. And when a green roof gets trampled, it is very difficult to get it back to what it was at the time when it was installed. And I don't care whose system it is. I've seen this all over the place. And it's, it's one of these things in construction management that really needs to be looked at. And we've gone to the point where we're actually writing a letter to the construction manager or the general contractor, basically saying, green roofs being installed in the next few weeks. Make sure that all your other contractors are aware of this and be prepared to back charge them if they damage the green roof.
Yeah, I think
Yes.
the establishment stage is such important because especially when you talk about traditional green roof, the plants are just babies, like they need that time, to establish. And just like yesterday, like we heard in Calgary, I mean, like in Red Deer, they talk about, in Alberta, how the plants take 2 years to establish because it's a native plant and we have to respect nature, respect that time. So if you don't do that maintenance in that, like baby stage, then it's just not fair for the plants, I guess.
Well, I mean, it's relatively easy to see too when a green roof is damaged by trades, like the one that's behind Karen or the one that I have on my screen. Neither one of those were damaged, or at least not in the areas that are visible, and you can tell very easily. When you stand on the rooftops in Toronto, when you look around, Toronto's one of those areas where you can turn 360 and you could probably see 10 or 12 green roofs from that one particular rooftop. And you can pick out exactly the ones where there's going to be trouble or there is already trouble. And again, it doesn't matter who the manufacturer is. When it gets trashed, it gets extremely difficult to repair.
No kidding. So back to the blue-green roof aspects, what do you think are the biggest myths or challenges for blue-green roof installations?
Probably the 0 degree construction that comes up a lot, that's not done, which it is. So I think that's one of the myths, in the industry, that you can't do a 0 degree roof. And like Richard had mentioned, it's just kind of simple physics. If there's a vessel for the water to travel to, it's going to. But I would say from our experience doing these projects, that's probably the biggest one we encounter.
I think the one that I encounter the most is the idea. In fact, it goes back to when we first started doing green roofs in what we now know as a green roof, as opposed to rooftop plantings. Because I've been in this industry for a very long time, and as a young kid in an architectural office, we did planters on roof decks all the time. But the idea and the resistance that the green roof market has had up until like the last 20 years is like all roofs are assumed they're going to leak. And that's a myth. That is not true. Some roofs will. Some roofs, if you don't, like Kees is saying, if you don't install them properly, don't watch your contractor, allow for various trades to trash even the membrane, those roofs will leak. But today, that's not an excuse anymore. There are roof membranes that your building will not need a new membrane for the life of the structure. And that's, I think, one of the myths that needs to be and continues to be overcome. We don't see it as much as we used to, but it is one of those ones that can come up when you're talking about retaining and detaining significantly more water on a roof than we typically have done in the past.
Great. We'll be transitioning to the Q&A in just a couple minutes here. But Karen, you had something you wanted to add to that part?
Yeah, like when you mentioned about like what kind of myths, and I find that one thing we hear a lot is about the misconception between the retention and detention, just like Kees has very clearly explained, like right at the beginning. Like many people would say, oh, you know, you're storing water on the roof, you're going to have a lot of weight, you're going to have mosquito problem, you're going to drown the plants, and all of that. I think the key thing is this is only temporary. Especially
Right.
in Ontario, you are only allowed to pond that water for 24 hours and you have to draw that down. So I think that one of the main thing about that is a lot of this myth about is because they don't understand, like people may not fully understand that the water is only temporary going to be there when we talk about detention. So I think that's sort of the key thing I want to bring it out.
Yeah, neither mosquitoes nor algae are going to take hold in, even 72 hours. It's when water is standing around at a certain depth out in full sun when you get into the mosquito and algae problems.
Excellent. You answered one of the questions I had on my list. So we're going to switch to Q&A, and if we run out, I have a few more on deck I can ask. However, we'll be done here at 3:30 Eastern. If you can also, panelists, be around till the 3:55 p.m. time period, there's also going to be a Q&A session then that it might be worth staying on, because I'm already seeing lots of good questions and comments. So I'm gonna go ahead and start. This one is from Corinne. She's asking Richard, could there be a wetland on a roof?
Wow. I think you can. It's a question
Dusty
of.
Gedge does it.
I'm sorry?
Dusty Gedge does it in the UK.
I know he does. Yes, he does. And I think, yes, you can do that. And it's a question of how you detail it. And how you manage the water within a wetland, I think is important. Because even in a wetland, the water tends to flow. And I think that that's something that you don't want it, like Kees is saying, you don't want it to get stagnant and you don't want it to create a mosquito hotel. But I think you could. I mean, it would require your mechanical engineer and your architect and your landscape architect and your wetland designer to kind of work together saying, look, and you can create a bathtub on a roof, you can create a pool on a roof that's not going to lose water. But now you're going to be trying to plant like a wetland or even a lily pond, like Karen was mentioning. Yes, you can do that, but that requires hydraulics. It requires things that keep that water moving so it doesn't become septic. So it doesn't become, because all these plants, some live and they go through the life cycle and die, and those byproducts of that cycle contribute to the natural evolution and processes that go on in a wetland, where you bring that to the roof and it's like, boy, that's some of the, you're gonna have to do some little extra maintenance on that one.
Mm-hmm. I can honestly say that we have done a wetland roof and it didn't go very well, and I think it was a byproduct of the movement of water on it. It was just stagnant water, and the plants obviously want some free flowing movement in water, and that's probably one of the missing pieces in the project. It was a bit of an experiment anyways, but it was tough. But I think it's the movement of water that was missing in that. So I'm glad you said that, Richard.
Well, the key really is that all plant roots need oxygen.
Mm-hmm.
And when water becomes stagnant, it loses its oxygen content. So when you can keep it moving in one way or another, it retains oxygen.
Vertically or whatever, or horizontally.
Yeah, in whichever direction. Yeah, as long as it can pick up new oxygen, that's really the key to it.
Mm-hmm. Right.
Excellent. And we have a attendee that said, great presentation. I understand that a blue roof doesn't work so well on sloped roofs. However, question, Dr. Liu, you mentioned friction detention blue-green roof can work on sloped roofs. Can you please explain how this works?
Okay, yeah. Sorry, I think I didn't really make it very clear earlier in my presentation. So the whole idea about the friction detention roof is normally we have a free drainage at the bottom of the green roof to allow all the excess water to come out, and then it will divert it into the roof drain. But in the friction detention green roof, this free drainage is replaced by a frictional mat. So this frictional mat, what does it look like? It's sort of like a sandwich, and in between there are little vertical fibers with like thousands and thousands of them. So meaning now when the excess water comes down into this friction drainage layer, it has to pass through all this like fibers, sort of like an obstacle course. So it's sort of like a bit of biomimic as well. Oh, thank you, Richard. Did you ask that question? Since you already bring a sample.
You're muted, Richard.
You're muted, Richard.
No, I just happen to have a piece of this in the office, what Karen's describing.
Okay,
Yeah.
perfect. So this is the piece that Richard is talking about. So I don't know if you can put it closer to the camera so we can see all the fibers in between. But basically, when the water goes through the fibers, then thank you. And then it creates friction. So the water becomes slowed down. So this is the same idea. Instead of using a flow control or control flow drain to slow down the water and using this to slow down the water, so you achieve the detention. And because this detention is achieved in the drainage level, so meaning that now you are not really restricted to just like one flow restrictor, that a drain, maybe one drain in like 900 square meter of area. So now you actually, it's the entire 900 square meter, is going to be your detention. So it makes it more effective and also allow the water to actually pond up back to the green roof before it comes back down, over the 24 hours period. So that's how it works. And I know that I didn't explain, maybe it's difficult to visualize.
Hey, Karen.
Mm-hmm.
Let me add something to that, because
Please.
because this is a big issue in the
Okay.
market for slope. So on top of that fabric is this material. Karen, you want to explain this?
Okay.
Sorry.
Thank you. No, Richard, like that's amazing. Like you brought all the sample with you. So
my entire office full of samples, let me tell you. But anyway, go ahead. I'll hold it right here.
So this is actually like a cell, like a retention cell. So it looks like, what does it look like? It looks like a honeycomb. So then it allows the water to actually pond, and then so give you a little bit extra space. So in case if you do want like an extra depth of water detention, so the water can detain in there, and then it allows it slowly to come down into the drainage layer. So again, you are holding the water, but it is all calculated so that the water will flow out within about 24 hours. And that's how it works. So maybe later on, I can put it down maybe in the chat box, some of the links so that you can take a look at it. With some graphics, it would be easier.
Great. Just a quick follow-up, Karen, on that. How do you calculate the weight with the friction layer? Is it just the weight of water?
Well, actually, the friction layer, as Richard's hold up, is only 5 millimeters thick. So it's actually very thin. Oh, sorry, the other one.
Yeah, this right here.
Thank you, Richard. So this is only about 5 millimeter thick. So let's say about 1/4 inch if it's in an imperial system. And so it weighs only about maximum when it's fully saturated, it's about 5 kilograms per square meter. So that would be, half a pound or so. So it's actually very, very lightweight, because even if it's fully filled with water, it's not a lot. But the idea is this, when it's fully filled, because the water takes time to go out. So more rain comes on, it will actually go into, the retention cells that Richard mentioned, or it can actually go into the green roof itself, so that now you can actually like allow the green roof to saturate a bit more than normal, and then before it actually to drain back out. So that works really well. And because of the slope roof earlier, we mentioned because of the slope roof, now all the water is actually not just ponding because of the slope. It's actually ponded within the green roof system. So that's why it works very well on slope. Thank you,
Excellent.
Richard, for bringing all the samples.
And well, and it's and Karen brings up a really good point about the weights, because when the structural engineers are asking all of us about how much does your assembly weigh, and we always give them, this is what it could possibly weigh. And the ASTM tests give that, what does a blue roof weigh if it were completely full, and how much does that green roof on top of it weigh if it's completely saturated? That's what the structural engineers want to know, because then they'll put their little safety factor on it, and that's what goes into the design of the deck, the steel, the concrete, or whatever it happens to be to support that particular piece. But that's a very, very, very important aspect of the design of these things.
Yeah, absolutely. We always have to calculate the maximum weight of the green roof anyways, but with the blue roof, just like Richard say, like with the retention cell, the honeycomb, as well as the drainage, it will add a small amount of weight to that as well.
Yeah, and I mean the same is true for the retain riser that we have. You have to calculate that water, and keep in mind that water weighs 5.2 pounds per inch, so it can add a lot of weight in a hurry to a green roof.
Or 1,000 kilogram per cubic meter.
That is.
In Canada, actually,
just to,
in Canada.
Well, and we did a blue roof, green roof in at this Biomed project, and it had 7 inches of insulation and 5 or 6 inches of blue roof, which we calculated at 5.5 because you can't get them all the way full, and then a 6-inch green roof on top of that, and that's 82 pounds, and it's completely saturated. And the structural engineer, we all thought he was going to have a stroke. We said, "Oh, okay, that's fine." When you deal with buildings like this, and that's important to understand with some of these guys, some of these buildings, they're already designing to hold mechanical systems that are weighing far more than what these blue roof and green roof systems are actually doing. And so I think that I would not be afraid of suggesting that some of these might be, depending on the requirement, could be 80 to 90 or 100 pounds a square foot. And so that's actually very common. As the insulation value goes up, especially, I'm not sure what's happening in Canada, but in certain areas of the United States, the R values are going up to R40. I know New York is going to R40.
We're already there.
Yeah, so you guys are ahead as usual. And that's we're struggling with, well, these parapets aren't tall enough when you're doing retrofits. And so how do you deal with that? How do you deal with the wind? How do you deal with everything else that has to go into that?
Yeah, Richard, we are north of you. We are much colder than you are.
True. Yes, exactly.
Right. Yeah, typically what I'm seeing now on the condos is 7 or 8 inches of XPS.
Yeah.
So it varies a little.
So that'll
bit.
get you to your R40 in a hurry.
Yeah.
Yeah.
So we only have a few more minutes left, but I want to ask a couple more questions. What are the other uses from the water on the roof? Can it be used for flushing toilets using separate storage tanks, for example?
I've been there. We did a project at the University of Western Ontario where they did that. They were capturing the excess water off the green roof into storage tanks. And within a few weeks of opening the building, they were getting complaints about residue in the bottom of the urinals and the toilets, because unless you really, really finely filter that water, there's going to be some dissolved solids in there, and they're going to precipitate. So if your client is prepared for those problems, that's not an issue. But conversely, why not capture the extra water and use it for your landscape, or even use it for your green roof to maintain that minimum 10% moisture value, especially if you're in a drier climate.
See, I like that. That part of it is we've been asked that same thing, and in Kees we've had that same experience in a project in North Carolina, where it wasn't even the green roof's fault, because all the water on this elementary school was being collected in a cistern that was underneath the parking lot. And within several months of opening the school, they had a significant and apparently nauseating smell coming up, and they had E. coli infestation in this tank, and it didn't come from the green roof; it came from the white roof.
Mm.
And that's kind of where the weird part of all this goes, because now we found out where all the E. coli issues in Chicago are coming from. No one's from Milwaukee, I hope, in here. They're coming from the birds in the water in Milwaukee, and all that stuff flows down. It's the birds that are doing this. So, and it really depends on which code that you're dealing with. So in the Chicago and in the United States, the plumbing code takes over at that point, because if you're going to put it, like for instance, you can't put certain pot, or you can't put certain recycled waters into an aerating or an overhead spray irrigation system. They have to be done by drip. And that requires heavy filters, in fact, in Illinois, the plumbing code requires it be sterilized to potable water standards. And that includes taking out all of the particulate matter that takes, and it's got to be clean water. And that adds dollars to it, but it is really the right thing to do.
Well, Legionella is the danger there. If you're basically making water into an aerosol. I believe the Canadian Building Code, as of two or 3 years ago, has basically said that you can't overhead spray recycled water in occupied spaces at all. So you gotta have it from drip irrigation. Now that also comes back into the picture when you're doing blue-green roofs and you're irrigating, you have to make sure that irrigation is effectively used. So that's one of the keys to it. Coming back to the question that was asked about recycling, the other thing is if you go to urinals, etc., with water from a cistern, you're also looking at a secondary plumbing system. If you cannot run that through the regular plumbing system, so now you're creating two plumbing systems. So in a lot of cases, it makes a lot more sense to put your tank within the floor of your major roof areas and simply reuse it as irrigation. So you only have to have a short run of plumbing to get it back up there.
Excellent. Thank you, Blue Green Roof panel. This has been an incredible discussion, and we've come up on our hour of conversation, but if you can return in about 25 minutes to do additional Q&A, because there are more questions, that would be terrific. Thank you so much.
Thank you, Jen.
Thank you.
Yeah, thank you.
Thanks.
All right. Well, thanks so much to Karen and Richard and Kees and Jeremy, and also Jennifer for moderating that session. It's really great to drill down into some of those facets of integrating these systems, and really appreciate your collective wisdom and experience.